Okay. Okay. I want to synopsize what we talked about last week. I had two videos, actually three, but two videos that were potential for today. One of them was the Mount St. Helens video. Now, I don't want you to fall asleep, so we're not going to watch the Mount St. Helens video. It is the video. There's a lot of really good information in it, but it's a man who is a scientist walking around some of the Mount St. Helens area with his 13 or so year old son and explaining to him what's happened, and it is slow. Okay, and unless you want to hit the fast forward button multiple times, it would be really slow. But he did point out the same things that I talked about last time, and he did a really good job of, he called it super, S-U-P-E-R. He said there are five major things in, when Mount St. Helens exploded and blew up and did all that it did, there's five major things that totally challenged the idea of the geological column, which is the idea that, all of these millions of years of these layers being built up and all of that kind of thing that's been going on. And you can remember the pictures that we showed, and you can picture some of them in your mind because of Grand Canyon pictures and stuff like that. But one of them is stratification. That's the S. And he said they found out that within like a week, 60 feet of stratification was deposited in that area. And if you look at it, it looks like the side of Grand Canyon, that they think took thousands of years to build up over the generations, over the millennia. And he said, that totally messed up the whole idea of being able to date things on these layers, like a tree's layers. And they've even found out that some trees grow more than one ring in a year, depends upon the weather and patterns and stuff like that. Okay, so S is for the strata, the stratification. He said basically what happens is when that lava is flowing, and not the lava per se, but the lava is part of it. But when that they call it a pyroplastic or something like that, when those gases come out, and there's a flowing of gaseous, liquidy mess, kind of the heavy stuff falls out first, and so that's your bottom strata. And then the next layer is the next dense falls out next, and the next one falls out next. And so it's a layering effect based upon what it's carrying in the flow rather than eons of time. And now, could it have happened over eons of time? That's been the common expectation with scientists for generations. However, they've all of a sudden realized that it doesn't take eons of time. That's number one. And he talked about the upright trees. And we talked about those, and you saw the picture of that. They said every time that you look at one of those, and there's a particular name that they call it, and I can't remember what it is right now, but the upright trees that have petrified, that is literally impossible to have happened in the standard way of layers being built on millennia at a time as it slowly built up, because the top portions would have decayed before they ever had a chance because wood's not going to stay woody for 1.5 million years. It's just not going to do it. It's going to rot. Okay, that's number two. The S, stratification. U, the upright trees. P is the peat moss. Remember I talked about the peat moss, and he said something that I think I remembered hearing, but I wasn't going to say it when we were talking because I wasn't clear in my mind about it. But the peat moss, there were already in 30 years. It was 30 years anniversary when he made this video, and in 30 years they had at least 3 feet of peat moss underneath the log jam that was up there. Okay, 3 feet of peat moss. That peat moss is exactly the same as the peat moss that you would find in swampy areas, or even like England has lots of peat moss in it. But there's that peat moss there, and they have taken the peat moss and they have put heat and pressure to it, And they have turned peat moss into coal in hours instead of thousands of years. Okay? What it takes is the right pressure and the right temperature. That's what it takes, and peat moss will turn into coal. Okay? So that's one that they all of a sudden it's like, wow, we thought it would take millions of years for this kind of stuff to happen. SUPE, erosion, like the Grand Canyon and the erosion. The erosion in some of those places where there was a big lake and it kind of like the plug got pulled and it all ran out. Within a week, it was days up to a week or a week and a half, it carved a canyon that was, I don't know if it was 100 feet deep, but it was a very deep canyon, and it eroded it quickly. And you look at the stream, and you might remember the picture in the Grand Canyon is the same idea. You've got this huge canyon, and you got this little river down at the bottom of it that they expect that was what carved it out over millions of years. And they realized that it didn't take millions of years to carve canyons. It just took a cataclysmic event. And then R is the restoration. The scientists expected to have lava and bare no growth for 100+ years in the area. And within 30 years, they already had forests. He was standing on a place where you could see 3 ridges. Okay, and the volcano blew up here, and the furthest ridge that you could see was already green. And the animals were back, and the animals were eating the grass, and the animals were, foxes as well as I think elk was the big ones that were there. And then you went to the next one that was the next closest, and already the lava had been breaking up. The ashes had been breaking up, and seeds were growing. And then the one that was the closest, it was still fairly bare. But it was like they expected that the furthest one wouldn't get any kind of growth for at least 100 years. And in 30 years, there it's already growing, and they've got trees taller than I am. At my house, some of you know where I live. When I bought my property, it was the two plots next to each other. They used them as a hayfield, and so they were baling hay there. So my 3 acres I keep mowing. The next to me was 6 acres, and now there are trees twice as tall as I am, and it's a jungle. It's not just trees; it's a jungle. It's trash woods. It isn't nice woods, okay? And that looked like that. It was just the growth had just exploded in the area. They found out that some of the animals, even in spite of the heat and stuff like that, some animals burrowed down when the trouble started, and they burrowed before the lava hit, or else they would have died. But they burrowed down. The ground living animals all ran. Before the explosion of the volcano, there was enough that they sensed it, and they all ran. And those are all back now. They're just it's populated. I mean, literally, he showed pictures, moving pictures of there's probably like a herd of 30 elk that were living in the area already. And so I just thought, SUPER, 5 distinct areas that totally confused the standard interpretation of how that kind of thing have happened. And so anyway, I just thought it would be interesting to share that with you because I thought, that kind of encapsulates it all. Kind of puts it into a little schedule that if you want to remember, you can, and if you don't want to remember, then you don't have to. No tests, you don't pass. This is not even a pass or fail class. This is just information that I think is interesting. Now, there's 2 videos that were on my mind other than that one, and that one, it was just boring. But one of them is called This Privileged Planet, and it's between boring and fairly lively. So, but it was intriguing to me, but we're not going to watch it unless you guys would like to do it another time. what I want to, and we're skipping about the first third of the video that I'm going to show you right now, because the first third is they got about 15 scientists that they brought together from every kind of branch under the sun, but they were all in a spot that they were beginning to question the validity of the evolutionary model. Okay. And some of them weren't, there's not even a Christian background, but they were just questioning. It's like, this does not work anymore. We've learned too much. This is just not working. And so the first, 15 minutes or so of it, they're introducing who they are, and they're talking about, just a little bit of stuff like that. And it's like, I was bored, and I kind of like science, so that was not great. But then we come to something that I think is just, and I hope you're not bored, because I think this is phenomenal. Okay. We've all heard of nanomachines, right? Nanomachines are things that are so small you can't see them without a microscope. But that's the next I don't know, breakthrough that they're trying to get in science, to be able to actually manufacture these little, and they think they can put them in your bloodstream and they can help fight diseases, and that they're ideas that they can do, that if you can figure out how to program something that's so small that you're literally trying to program atoms, okay, how does it get power? Because they're machines. Machines don't run just because they're there. Machines have to have a source of energy, okay? And what scientists have discovered in the last 50 years or so, maybe even less than that, they have gotten into the inside of the human cell, and they've been able to, with electron microscopes, actually see the activity inside a living cell. And your cells are full of nanomachines. They are literally little, and some of them are made an atom at a time. But you've got little machines inside you that their energy is sugar. The food that you eat fuels them, okay? And some of that is, what's the word I'm thinking? Some of that also refutes the whole idea of evolution, because you're going to see something in here that I think it is so phenomenal. I don't even want to spoil it, but it's so phenomenal because it's like, how could that have just happened randomly? It would be like we have a junkyard full of a bunch of junk, and a tornado goes over it, and when the tornado gets past, there's a 747 sitting there with gas in it ready to fly. It's just not going to happen. I'm sorry. It's just not going to happen. So, Larry, if you're ready to start that, and I went to where I think the thing kicks in, but if there's a little bit boring at the start, please just be patient, because it gets really, really interesting quickly.